Hi, everyone. Today our talk is Agents in Kubernetes 101, a crash course on cloud-native AI agents. And my name is Nina. I'm a software engineer at Solo, primarily working on an AI gateway project called Kgateway, and it's a data plane called Agent Gateway. I'm also a member of the Cloud Native AI working group. I'm working on some white papers around security and agentic standards. And my interests range from ingress gateways, AI agents, Istio, and I was actually the 133 release lead for the Octarine Kubernetes release.
And I'm Nimisha. I'm an engineer at Confluent, where I help manage a large-scale Kubernetes platform with thousands of clusters. I'm also a member of the Cloud Native AI group, and that's actually how I met Nina. And one of my interests of late has been how to use AI for managing cluster operations.
Cool. So first, we're going to start with a little story. So a lot of you might have interacted with an LLM where you copy and paste some code into it. And the LLM does a very good job answering your question. So if you copy and paste, like, can you fix my YAML spec? The LLM has been trained on a lot of code, so it does a pretty good job identifying the issue and telling you the answer. But what do you do if your LLM needs extra information? So if I ask my LLM, like my ChatGPT, what the weather in Atlanta is today, it doesn't have that information in its training set, so it can hallucinate and give you an answer that doesn't make a lot of sense, even though today was kind of cold, so I don't know. So the way we solve this problem is with tools. So I can ask my LLM what the weather in Atlanta is today, and it has access to like a date tool and a weather tool. It uses those tools to add extra information to the data it already has available and gives me an answer that's actually correct. So this is great, but you might want to keep asking the LLM questions. So in addition to asking what the weather is today, you might want to ask a follow-up question. So what's the weather today, and what's the weather tomorrow? And the weather tomorrow question requires the LLM to know the chat history and the session information. So how do you solve these two things, like knowing, having access to tool calls, and also managing the history of the user interactions? So what do you do if your LLM needs extra information? You use agents.
So let's quickly define an agent. In most frameworks, it's essentially just a collection of three things. System prompt, or something that sets the behavior or configuration for the agent, a model that everything revolves around, so LLM, for example, and then a bunch of tools that the LLM can query. So usually the loop goes like this, where you have a user prompt where you ask an ad hoc question to the LLM, and then it will decide when it needs to gather more information or execute some action on your behalf, call the tools, feed it back into itself, and do this until it fulfills your prompt. So we can dig into each of these three pieces, starting with the system prompt. Everybody here is familiar with prompts, I'm sure, but just to touch on this a little bit, a system prompt sets the behavior for all interactions. So for example, here you can say, you are a pirate-themed assistant, and the user prompt is the one that you give at runtime. So you may ask, like, what's the weather? And then when the LLM processes these inputs, it uses both prompts to respond to you. So it will respond about the weather in pirate language. That could be fun. The second component is the tools. So this one, think of it like functions that your LLM can call to basically either search stuff. So search the internet, code, docs, whatever it is, or execute actions on your behalf, like sending emails, creating calendar events, or making even external API calls. And tools can be anything. They can be stuff within your Kubernetes cluster or stuff that's outside of your Kubernetes cluster. And you tell the LLM usually at the beginning, like, what tools it has access to, and then it will decide based on the prompt what it needs to invoke. The problem with tools, though, is that, first of all, if there's too many tools, an agent can get confused. Each tool may have its own identity model and secrets, so authentication is different. And there's some overhead to integrate all of the tools with your agents, and separating like which agent has access to which tools and so on. Also, especially, it's difficult if they're all implemented using different interfaces or languages. So what you need to glue this together is like a common language that both sides speak. So that's where MCP comes in. MCP is an open source standard for connecting AI applications to external systems. So what that means is, as long as your agent speaks MCP, has an MCP client, it can interact with any tool that also speaks MCP and has the MCP server side implemented. So that way, the community can grow while, basically it doesn't have to be, it can be decentralized. The community can grow around this. Apart from all this, what else does an agent need? There's a few other things that Nina touched upon earlier. So things like conversation history and task context and system preferences, that constitutes like the memory piece for the agent. Apart from that, there's the orchestration piece. So stitching together all these tools like managing multiple agents with different models. And there may be other features involved like caching to reduce your latency and costs. So this is where a framework really helps because it lets you focus on what your agent should do, like your business logic, and not how to manage all of this infrastructure around it. So with that, we introduced this project called Kagent. In one sentence, it is a Kubernetes-native framework for building, running, and managing AI agents. The goal with Kagent is to define and run agents in Kubernetes very easily and safely. It's a sandbox project. And on the right, you can see like a simple YAML spec of, basically, it's just the three things we talked about earlier. So it's got the description, model, system prompt, and then the tools.
Cool. Then with that, I think the best way to see Kagent is actually trying it in action. So we're going to try a live demo where my demo is actually broken already. So I have a mystery bug in my system that I'm hoping Kagent will help me fix live. But my setup is a local kind cluster, just single cluster. I have an ingress gateway that I've configured with the Kubernetes Gateway API. So that just required two resources, a gateway resource to set up a listener, and an HTTP route to set up the routing from my ingress gateway to my demo app. I'm going to use Kgateway as my Gateway API gateway, but these resources work with other gateways as well. And then finally, the demo app. This is a pretty cool demo app that Lin Sun from Solo actually developed that can connect to a local Ollama model. So hopefully, if we get this demo working, we can actually try it out and see what the demo app can do. I think the last thing I want to call out actually is the two tools we're going to use. So we're going to use the built-in Kagent tools. And these are going to be things that allow us to apply config to our cluster and get config that's already applied to the cluster. So I'm going to pull up my VS Code where I have K9s running. So this is like a nice visualization tool that you can use to kind of see what's happening in the cluster. So at the very top, in the default namespace, I have the demo app I mentioned. So this is the demo running. I have my ingress gateway, so that's also running. The ingress gateway is getting configured by the Kgateway controller. So in the Kgateway system, I have this controller. And you might notice there's a lot of different other pods all in the Kagent namespace. And these are all the default agents that come out of the box when you first install Kagent for the first time. So let's take a look at our Gateway API configuration. So the Gateway API, again, resources are the gateway piece. So this is just selecting, defining that we have a listener on port 80. We're going to port forward that to be able to reach our demo. And then the route resource that I mentioned. So this is the HTTP route resource. And again, very simple. It just sets up a simple rule to select the demo service that we looked at earlier. So all traffic is going to go to the demo service. I have Ollama running locally with Ollama serve. This is just a requirement that my demo app needs. And then I have a port forward set up for the Kagent UI, which we'll use to debug. And then my last port forward is for the ingress gateway. So you saw the listener was on port 80. I'm just going to propose 8001 to be able to port forward and see that demo. So unfortunately, when I refresh my page, you can see that I'm getting an error. Let me zoom in, maybe people in the back. Very sad, route not found. So something's misconfigured. So what we're going to do next is open the Kagent UI. This is the other thing I port forwarded. Let me zoom out so it's a little easier to see. And these are all the agents that we saw running as pods. But what we're going to do is actually create a new agent from scratch. So the agent name is just going to be like debug agent. The namespace, I'm going to select the Kagent namespace. The reason for this is I'm actually going to reuse the model config I already have in the cluster. This resource just has to match whatever namespace you're using. I'm going to use the declarative agent type. You can use bring your own, but we're not going to be demoing it in this talk. And then the description of the agent is actually non-facing to the agent, so it can be anything. So I'm just going to, oh, not there, type random text. And then, so like this is just for my own purposes, like the agent won't actually have access to it, but this is the system prompt. So this is actually important. We're gonna use the default system prompt because it does a pretty good job with the format and things I need. But the main takeaway from this system prompt is it's gonna nicely format my outputs, and it's going to make sure it confirms with me that I wanna actually do an action. So this is just the default one that comes out of the box with Kagent. And last piece, if you remember Nimisha's slide, we need to select some tools. So these are, again, all the built-in tools that come out of the box with Kagent. But we're going to focus on Kubernetes, because that's what we're debugging today. So I'm going to select the apply manifest. That seems useful. Create resource, sure. Delete, I don't know, maybe. And then get resource YAML and get resources. So I have a selection of 5 tools. You can select more, but if there's too many, the agent can get confused. So let's save our selection and create our agent. So if I scroll down, you can see the agent isn't ready yet. The reason for this is if we go back to our K9 setup and look at the pods, you can see that there's actually a pod that's coming up that's not ready yet. So our Kagent controller is actually, the UI created an agent resource called the debug agent that has all the config we defined in the UI declared as YAML that's been applied to the cluster. So then this is what the controller looks for, and now we have our debug demo agent spun up. Where is it? And you can see it was just created 35 seconds ago. OK, so now let's actually chat with our agent. I have a pre-filled prompt so I don't mess up. Where is it? OK. So this is just to save time because it's a lot of text. So if I refresh the page, you can see our debug agent is ready. Again, this is the response the description we added, but it's not actually going to get used. So the prompt I'm going to ask is, I've port forwarded my ingress gateway in the default namespace, and I've gotten this route not found error. Remember the error that we were seeing earlier? So even though my HTTP route is set up, how do I fix this? So let's, fingers crossed, hope Kagent can figure it out. So first thing, it says that it hasn't called any tools. So it says that it needs to check some config. So check the resources in the cluster. So OK, now it actually does some calls. So it does some tool calls for us. So it uses the k8s get resources. And you can see the arguments here, like very similar to what you would do with kubectl, like the namespace, the resource type, and then it spits out the resource itself. So it looks like the issue that we had was the HTTP route was linked to a gateway that was in the K-gateway system, but there was no gateway resource in that namespace. It was actually in the default namespace. So it says to fix it, we can do a couple things, but let's just try the HTTP route change, because that seems like it's only changing one resource. So update that, we'll send it, and then hopefully it's going to use the apply tool to actually apply the correct config. So it's asking me, do I want to update the parent ref? Yes. And let's see if it actually calls the tool. OK, so it calls get resources. Yes, proceed. Update, please. Come on. OK, so we got the apply manifest. So let's see what arguments it used. OK, it did the whole YAML, and then it looks like it's configured. So now let's see if our demo is actually fixed. So if I go back and I refresh the page, whew, the demo is fixed. So the next part of our demo is we're actually going to have a little competition in the room and see which side of the room is more engaged. So I know this is kind of a weird room where we're split. So let's start with the left side and see what our engagement level is. So again, this demo app was developed by Lynn to connect with a local lava model that I showed earlier. So let's see how the left side, ready left side? OK, take photo. And then right side. OK, so let's see. It's trying. So the lava model is like an open source model that's not as great as the models we were using for the actual debugging. But let's see how it did.
First image. Participants seated facing front, with varying engagement levels. Second image. Participants standing facing multiple directions. Fostering interaction and networking. The second image has a higher level of engagement as it promotes physical activity and diversity.
Okay, good job, second tool.
Leading to more active participation compared
Okay,
to
let's stop that. Cool, so we saw a single agent with direct tool calls. So the next thing we're gonna do is actually show an example with multiple agents. So why do you need multiple agents? You might want specialization, so your agents might be specialized to use a specific language, they might have specific domain expertise, or you might wanna use like a smaller model for a simpler task. So having nested agents lets you kind of do that. You might also want like a decentralized orchestration where you have a planning agent that kind of assigns simpler tasks to sub-agents. But the way that Kagent does this in our framework is using A2A. So similar to MCP, A2A is another protocol. It's a common language for autonomous collaboration for multiple agents and allows the agents to kind of talk, share, and coordinate with each other. So there's two main pieces that you need to know about A2A. There's the agent card piece, so that's like the agent business card that has all the metadata about the agent that describes like the inputs and outputs it expects, the capabilities, things like that. And then there's the discovery component. So that's the piece that the Kagent controller handles, and it lets the agents find and connect other agents dynamically based on the capabilities and roles assigned to them. So if we go back to the weather example in Atlanta, we can rewrite the same example using agents. So I have like a nested agent, like the client agent, that has access to two sub-agents. One's like the calendar agent that can get the date or like manage your calendar, and another agent that can get like the weather information, like the wind speed, the temperature, things like that. So you can imagine doing the same example we saw before, but with A2A. So we're going to go back to our demo environment, but this time we're going to apply a nested agent using YAML. And that nested agent is going to have a K8s agent. So this is not a tool. It's going to be like a separate agent that's responsible for doing Kubernetes actions, and a Helm agent that's responsible for answering Helm questions, and then a GitHub MCP server example just to show off the MCP server part. All right, so let's pull up our config. So let me apply it first, and then we'll look at what I actually applied. So the first config that I have is the nested agent I mentioned. So this is a slightly different system prompt that kind of highlights what tool and what agent should be used for what. So the GitHub server tool will be used to interact with GitHub. The K8s agent will be used to interact with the cluster, and then the Helm agent will be used for managing Helm releases. And then under the tools section, I now have an agent here. So this is the Helm agent, Kubernetes agent, MCP server. And then the MCP server just has a couple tools listed, so it can only list and get pull requests. So this MCP server is also declarative config in Kagent. So this is the second resource I applied, the MCP server resource. The MCP server in this case is using the open source GitHub server resource with NPX, and it's using my own personal access key that I've defined in a Kubernetes secret. So with that, let's double check that our agents are actually up. So I think it was called nested agent, so it should be running here somewhere.
It's down.
Oh, is it down?
Yeah.
Oh, I'll check the UI actually, maybe that's easier. Okay, so if we go home and refresh, nested agent, yes. So this agent can do anything. So let me start a chat with this agent. Again, I have some pre-filled example prompts that I've been testing. So the first question is, what's the image version of the K-gateway controller? So let me ask that. So I'm expecting this question to be answered with my K8s agent. And it looks like my nested agent did call the correct agent. This is interesting because it's very different from the tool calls we saw earlier, because the input isn't parameters, it's a request to that agent. So my nested agent is sending a request to the sub-agent, and then the output is also like natural language, right? Okay, so it looks like the version I have is 2.1 main. That looks correct. Let's ask a second question and see if it can use the Helm agent now. So what Helm values do I have set in K-gateway that are related to agent gateway? So that's one of the projects I work on. So I apply that. Again, it calls the Helm agent, so we did that correctly. And it looks like the output, it just has one Helm value, which is correct. And that's saying that it's enabled. So we successfully called the Helm agent. And then the last piece we want to do is test the MCP server agent. So the question I'm going to ask is, what PRs are open in the Kgateway repo that are related to Agent Gateway? So very relevant to me. It's like, what do I have to review today? So I asked that question. It calls the list pull request. So you can see that this call is actually very different from the agent calls we saw because it has the structured parameters. And then the results are also structured based on the GitHub MCP server. Let's scroll down. Oh my, there's a lot of open PRs. And you can see that these are actually real PRs that are open, so I can open them. And because it used the real MCP server, it did that. So cool. Back to the slideshow. Oh.
Yeah, OK. So to wrap things up, what makes Kagent different from other frameworks? Because there's a lot of them out there. The thing is, Kagent was built to be cloud native. So it's all declarative, YAML, familiar pieces. And you get all of these Kubernetes features right out of the box, like RBAC, policy rules, security, all of that stuff. Secondly, it allows you to have repeatable workflows, so there's less randomness in your interactions, and then you can also distribute it easily. You can templatize your agents, tools, use version control or GitOps flows. You can customize it completely, so you can have anything as a tool as long as it speaks MCP. And you can also bring your own agents developed outside of Kagent and run them on the Kagent runtime. You can also do more complex multi-agent setup, like the A2A example, to have dedicated or specialized agents for certain tasks. You can do web search. And there's this new integration into Kagent called K-hook, which is really cool because it allows you to do event-driven agent invocations, which means you get to take the human out of the loop when you're actually invoking your agent. They're really simple to build. And also, finally, it integrates easily with any CNCF project because basically anything that's running in your cluster. But there are also other projects in the agent space in CNCF. So there's K8s GPT, there's Cape and Dapper as well. Feel free to explore these and see what works best for your setup. If you're interested in learning more about Kagent or getting involved, here's the Kagent community repo, Kagent community website and the repo on GitHub. All the demos from this presentation are also available open source. Feel free to run them on your own if you want. And then shout out to this party that's happening on Wednesday evening. It's called the MCP and Agents Community Party. Feel free to take a picture or scan this and attend it if you want to network with more people working in this space. I'll wait a couple of seconds. Cool. Yeah, and finally, as we mentioned earlier, we're part of the AI initiative. So there's a Slack channel on the CNCF Slack. You can join that channel, and then there's a bi-weekly meeting. Most meetings, there's some really cool demos to see. On top of that, the group works on many different initiatives like white papers and setting standards for things as we navigate this evolving world of AI in Kubernetes. And yeah, with that, that's all we've got. Thank you so much for attending. We have some time for questions, and then also feel free to leave feedback for the presentation. Thanks. Thanks.